And we're talking about Chapter 10, Information Systems Development. Basically, this chapter is showing you how does the idea of a computer program becomes a reality. How all these business processes that we have, that we live, that we work with, actually come to be uh, something for all of us to use, the utilitarian function of an application. It's all based about the concept of programming, which basically says it's a set of instructions, logical, in a process called coding. Instructions are added by the developer when he or she encodes a design into a new programming language. And we can get into different formats of languages. We can get into different ways of doing programming, as simple as writing in plain English, or as complicated as writing on machine language. If you ever heard or worked with assembler language, that's basically what we're talking about. We're talking about working with machine language at that point. It's not easy to do, but that was the original set of formats that we have when we began working with programming. So when we're talking about anything that we do in information systems, we follow a methodology to develop something. I keep mentioning to you the term workflow. Workflow is basically the set of instructions, the set of steps that we follow to do a process. If you think about it that way, a program that you write, software that you use, is basing its information on a workflow. So a workflow is a series of steps that you follow, you design, you create, you put in place until you get different options available to you. As you create that information, as you create that workflow of information, you have different options available to you. And I forgot to start sharing. Oh, everybody can see my PowerPoint, right? You can see the presentation. Good.
Yes.
Excellent. Thank you. Okay, so the methodologies, if you think about it, or the workflows that you're available, you have what they call the SDLC, Systems Development Cycle, Life Cycle, or an RAD, or Rapid Application Development, Agile methodologies, and Lean formats. It tells you what kind of a format does he have, what kind of a flow does he have. It's very structured, incremental, minimalist, the type of analysis it does, the design format. Michelle. So when you are thinking on writing software, or when you sit down with your team and design a program format because you want to create a process and you want to automate it so you can use it, then you can use any of these methodologies. This is the most common that you're going to find in the markets, is the different options that you're going to follow basically for the applications, because you're actually given the system the option to create something for you. It's organized, it's structured, it's the idea of coding, putting something into a design format that you are looking into to make it run on a computer. Well, one can argue that all these methodologies, all these formats that you see here can be used on almost every application of business cycles. And we're gonna see it like this. When you start seeing, for example, the SDLC, or Systems Development Cycle, It's also called the waterfall model. It means that each item has to be done before you can go to the next item. And what is designed for you to do is basically for very large projects. It's not for small projects. Yes, it can be used for any format project you want. It's mostly used for the big projects that you have. I'm putting in here different labels because depending on where you look, you're gonna find different ways, but it means the same. Preliminary analysis is the same as the requirement analysis. You sit down with your team and think, what do I need to do? What is it that we want to accomplish? What business process are we looking for? System design, we start looking at what are the items that we're going to need, specific requirements. We haven't done any programming yet. We are just using whiteboards, pencils, papers, chalkboards. We are just brainstorming with your teams. How is it that we're going to develop this? What is it that is required? So remember, on your requirement analysis, your preliminary analysis is what is the problem to be resolved? So that's your problem question. On your system design, you're saying specific requirements of the new system. No programming is done. This is when you get the main people that are affected by this, people that are involved on this, to start talking to you. I keep mentioning to you the concept that capital, human capital is the most important. Very often, when we design systems like this or processes, we don't include the end user. The design system, the systems analysis part, is the option that you have to go back and talk to the line user, to the cashier, to the bagger, to the stocker, to the uh, line supervisor for details on usage and applications. What steps are you missing? Remember, managers tend to give you the broad view. They're not going to get into details, they forget details. So they have to go back to this. Go to the lowest person on your line and ask him the questions. They need to be included in there. And you will find out there are a lot of details that they know that you as a supervisor, manager, or your manager's bosses don't realize because they're not involved at that level. So when you're thinking system design and you're looking at specific requirements of the new system, then be able to do it. Point in case, you design an inventory system that is going to be ultimately used on multiple type of machines, especially handheld items, and you are using scanners and using all sorts of stuff. You have a warehouse that is in Phoenix, Arizona. Average temperature in the summer 115 degrees. That means the floor of the parking lot of the warehouse is probably at 120 degrees or more on the shade, in the shade. Well, you develop your application, you have it already, you are proud of it. You go to the floor, tell the supervisor of the floor, go use the scanner to so we can inventory the trucks and the parts we have in the on the yard. It's so hot, your system crashes because you never considered asking the people on the floor, how hot does it get in there? Do we have to consider heat as part of the requirements of the hardware and the software application that we're going to be using? That's why it's important that system design includes every person. This is where you're going to document all the procedures. This is where the key players are interviewed. This is where data requirements are developed. You need to get a broad, big impression of what you want done before you move to the next design, the next step in the model. So technically, you can go to the design, to the object design. Nobody's going to stop you. However, if you have a problem and you go to the object design, by the time you get to testing and you find there is a problem, you're going to find out the problem was a system design because you never bothered to check with them at every level of your manpower to determine usability, requirements, documentation, key players are needed. The optimal solution is that you cannot move to the next step until you have completed all the steps that you needed. So before you go to object design, system design is complete, and so on and so forth. In system designs, that's where the designer, your systems analysts, your programmers, your engineers, and you take all the information that you have on the system design, and now you get into technical requirements. And also at this point is where you introduce the business requirements that you have and you translate it into technical requirements. Again, if I say inventory items, inventory your warehouse, that is part of a business requirement because as part of inventory control, as part of finances, we have to know what have we purchased, what have we stocked, what do we have left. So the business requirement is called an inventory. The technical requirement is what are we going to inventory? How are we going to inventory? Well, we have barcodes. We don't have barcodes. We have to assign codes. It's too hot outside. We need to make sure that at what point do we count this material as it's coming in from the truck, as it's stored in the warehouse, so on and so forth. So this is where you're stepping in and you're designing these requirements into the system design. At this location, at the system design, the object design, is where you start working on the user interface, the database, the data inputs, outputs, and reporting options. So one part of your team gets involved on saying, I need to know the following. A second part of your team tells you, I need to know this. Your supervisor, your boss says, I want to know reports that say the following. HR says, I want to know time. I want to know work produced. I want to know widgets per hour produced so payroll can match that information. So you are getting all this information together at this point. Your teams are working, you're supervising, or you're part of a team, you're working on this object design or system design. Finally, we exhausted all the options. We are content with what we have. Now we start writing code or programming. This is the part where we actually decide what are we going to use. The system design is a documentation guide. Programmers develop software. Uh, this is the result of the initial working program that is meeting the requirements of the system design or your systems analysis. And then the design that you included on the object design. So you notice that as a waterfall moves, you're working on all the steps. One is codependent on the other. Your programmer, your developer, your software engineer, your coder, these are the people that are be doing the code, lines of code, on Visual Basic, on C Sharp, on C++, whatever the option that they recommend for you to use, they're going to be using. So that is coding. So you work on all this, everything is working right. Now we go to testing. This is the program that has been developed, is going to put through the paces of different tests to make sure it meets the requirements. For example, you may tell it, load the whole database of purchases. Can it handle that information? It's millions and millions of records. Okay. Can it handle payroll? So the payroll people will come in plain and said, okay, it's supposed to be doing the following. If we were to follow the payroll from last week in here, it's supposed to give the following results. They're going to be checking for key codes, key responses in this option. If for any reason fails, option number one is incorrectly coded. Option number two, which is the more likely one to happen, you have a problem between requirement analysis and object design. If you think of a flow chart, you go to the beginning, you start, you come back to the starting point to refresh and to restart and figure out what is happening in here. What you're trying to do is that all the standards required are met. Any bugs or errors or problems found during testing are resolved, and the software is tested again. Now, knowing what you know right now about this waterfall model, being at testing, can you think of an application that you have used in the past where you can tell that it has never gone through this process because you are actually reporting the problems and you, in essence, have become a tester? Can anybody tell me something like this? Everybody venture to remember or to realize something that you've been working in the past with or even recently? We're talking software, people. Well, I'm going to give you the most obvious one: Microsoft Windows. How many times have you run into problems with your Windows installation, with your Windows software? And you get a little message saying, send this to us so we can tell there is a bug. You, in essence, have become the testing part of a fully developed piece of software that you're being charged for and you're asked to hold a license to, where quality control has been left to the consumer. You see it all the time on many applications. When they crash, Google Chrome is notorious too. If it's for any reason it's unstable, it will send you a message saying, we crashed, ouch. Send this message back to us to tell us why. Better yet, when you install the software application on your computer, it asks you if you are willing to participate on programs where you provide feedback to the company on the software operation and crashes that it may have. You are, in essence, producing the testing of this waterfall model. And you just install it on your own computer. You are doing maintenance because you are seeing the results of a problem. You continue to work with the problem the way it is, but when you send the result back, Microsoft, Google has to start working on what is the problem. Why is it that we don't have the resolution that we want? Well, lo and behold, we know what the resolution is. You have a new Windows application available now. Windows Me, Windows Vista. That was a typical example of a problem where they have fallen through the crack, put something really bad out there, and expect it to work. It didn't work. Now we have the issues that we have. Well, now we're on Windows 10 and they're announcing Windows 11. But you, the consumer, have been doing the testing and the installation and the maintenance, holding the license, and having to work with product that can be, in many cases, unstable or no good. So again, we go to implementation or installation. The new system is developed, tested, implemented in the organization, providing documentation, data. So you have at this point a system that is operational for you. Now you can go to distribute the software to users and begin working with it. In many cases, the question that you're going to receive is how urgent is for this application to become available. Thus, the issues that you have or that you see when software is being produced that is lacking maintenance or quality control, and you do it yourselves. All right, maintenance. Once everything is complete, you have maintenance. In big application software applications, you have maintenance licenses in which once a year the owner or the manufacturer of the software sends you updates and updates your systems, take everything down, implements new things. And we see it all the time when you get a message from Microsoft. You have to restart your computer now because you have a new update. For the Apple users, you have a new iOS update. You ignore it. Eventually it tells you you cannot ignore it anymore. You have to update your operating system. That's how they're doing the maintenance. Technically, they're doing software updates, backups, so on and so forth. So these operating programs can actually work for you. Again, the waterfall model, a very rigid and a structured model, is usually used for very large applications. However, it can be used for any kind of application at any time. It is good because it forces you to go through specific steps before rushing into different ways of doing the code and doing the processes and everything. You actually have to be more detailed when you're working with it. Then you have the rapid application development, or RAD. It's a model that in essence is being used uh, for building models, working models very quick, and getting feedback from the user. As the feedback is received, it begins updating the users. So in essence, the feedback is received, the model is updated. Put out again, more feedback is received, more updates are received. Once you get to a point, a determined point, you go back and says, okay, we have enough feedback. We can actually go with it. You move with it, and the final version is put out for development. It doesn't take as many steps. It's much more compressed than the waterfall model, and thus is designed for smaller projects. They say it's not as resource intensive as the waterfall model. The Again, the biggest issue you're going to have is how small of a project this is. How detailed do you want to get? If you're looking at getting into detailed information on what you're working with, you may want to consider the waterfall model because you actually can track a lot of information and more detailed information that you're doing with a program like RAD. However, RAD will work for a quick and dirty development, doesn't take too many users, the feedback is quickly and effective, and after you exhaust the feedback, you can produce the final version. Think of the RAD for something like an app that you're building for your shop, something small that you can track. It's not a mass production items. The requirement planning, which is the first phase, is very similar to the preliminary analysis, the systems analysis, and the design phases of the SLDC. So all these three, requirement, system, and object design, are the requirement planning. They become one. So yes, you're doing it all at once, but it's not as detailed. You define basically the overall requirements. Your team is identified, the feasibility is designed. So you say, can we do this in this shop? Yep. How many people we have available to work with it? Okay, we have enough. Is this the project? We can do it. Yes. So there you go. Requirement planning is done. As opposed to go 3 different steps with the waterfall model to make that decision. The user design. So basically you went from here, requirement planning, to user design. This you're working with the systems analysts, designers, programmers, and create what is called a joint application development, a JAD. And these are sessions that are designed to facilitate the work between different peoples. So this is like getting the different shops together and says, okay, what you guys got, what you have, give me your information. You develop an application development, a joint application development format, and then all the information is shared, and they begin working on the design. As opposed to the object design in here, which is a single task and coding. So we say when you do requirement planning, you're doing the first 3 options of the waterfall model. But also when you do the user design, you're using part of the 3 items on the waterfall model, which is the coding part and the user design. So basically you're trying to create a structured discussion before anything moves forward. The difference is the application developer, the programmer, is already participation on the discussion in here. So he is being involved already on the decision-making process and the design of the model. So he's not coding yet, but he's getting involved on the process that is going to happen. So then you have the construction part. In this part, that's where the coders begin, the programmers begin working. That's what everything began to develop. The programmers and the developers begin actually constructing the format that you want, the actual shape of the software design that you want to put it into place. Again, they're using it on in a format that multiple discussions are going, and at the same time. And all these changes are put together by this team, and they're putting it together for the user design to be a more acceptable of the product developed. So you go from here, from the user design, where you have a bunch of people working with you, including the programmers, to this session, where you have the programmers and the developers putting all the information that they have together to put something together for you, and go through what is called the cutover, going from the old system to the new software. And that is where they say, well, this is crucial. How fast is it going to be done? How is it going to be done? Usually they try to schedule where there is low activity. In many organizations, this process at this point is where you use a parallel process in which two programs are being run simultaneously. While one is tested, the other one continues to be in operation. Then a cutoff point is found, and then all the bugs are being eliminated. In this case, the feedback back to the users is being received for the final production and final push of the software. So you may have models running at the same time, or they actually do actual cutover at a point in which there is low activity. They may choose to do phases. One section goes to finance, one section goes to HR, one section goes to accounting, one section goes to shipping and receiving, finally production, until everything is implemented. The most safer and productive way is the parallel system. It's also a very expensive way of doing it because you have to maintain one system running while at the same time you implementing the new system. Usually resources is going to be the biggest problem, because if you have all the programs running in one old system and brand new system is going to be tried to run in place, you need to have software and hardware availability under the new system. That way you can still run and compare against the old system. So we see that RAD is very compressed, but many of these steps are combined. Again, it's designed for the smaller projects because the user has the ability to provide feedback throughout the whole process. So again, it doesn't mean that the SDLC, or the waterfall model cannot be used. It can always be used. It's more constrained, more limiting, but the RAD system allows you to use it at the same time because you are going to combine steps into one format and then move on into design, construction, and then finally production. Uh, so that is RAD. And then after RAD, then they have what is called agile methodologies. Methodologies that utilize incremental changes with a focus on quality and attention to detail. This is with each increment is released in a specified period of time, creating a regular release schedule with very specific objectives. This is a very thorough process, and it allows for a user interaction and flexibility to change. However, if you think about it, in order to have this fully implemented, if you have a large application, you cannot shut down the whole company and expecting to release something and then shut it down, the old system, and put the new system in place. Usually you have done this when you be running in parallel. where the old system is still running, the new system begin running and says, okay, new system is running, is doing everything we want, effective August 1st, goes away. So you have a specific period of time and you have a release. The Agile methodology is based on what is called the Agile Manifesto. And I'm going to share my screen with you. Because basically the Agile Manifesto is saying, when it was written, we are uncovering better ways of developing software by doing it and helping others do it. Through this work, we have a common value: individuals and interactions over process and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, responding to change over following a plan. So far, the manifesto is talking about very plausible things. Responding to change. That's very much like the RAD part. Customer collaboration. That's part of RAD also, because you respond, you see customer collaboration, they provide feedback. Working software, part of RAD also, because as you are getting feedback, you are working on interactions until you cut up and say, now it's time to produce. Individuals and interactions, well, that's part of both of them, because on the RAD specifically, you are compiling everybody that works on the project and you are bringing them together, including programmers and developers, to put their 2 cents in there and determine whether this is something that is plausible or not. The manifesto was written by these people to facilitate and enhance many of the options that are out there for when writing software. I'm gonna stop sharing that. I'm gonna make sure my PowerPoint continue to share. So knowing what we have at the manifesto, they plan, they collaborate, and they deliver. They're constantly reviewing. They're constantly working on feedback. They receive the material, they receive the plan, and they begin working on it to deliver on everything that they have to have on a very specific timeline with very specific objectives. The agile methodologies are very much involved with, even though they're considered apart from RAD, as I said before, both of them are sharing the same ideas, the same principles, which is important because you need to have that in order to be able to produce something that is feasible for you and the customer. The interaction, the center item in here, is the key part of the agile methodology. It's always receiving feedback and moving forward with it, feeding it back, reviewing it, and working with everything that it has. It still continue to receive information on the plan. It gets to a point that the plan is done, but now we begin working on everything that we have, and we go to a deliverable that give us feedback, and we come back and do it all over again until we have everything done that we need to have in order to have a viable product to work with. In other words, agile development means constant evaluation by the developer and by the customer. They are basically set up on small teams that are made of people from different parts of the organization, including customers. They're set up on short time frame increments from days to weeks, no more than that. And you're working on a project that is always showing progress to the stakeholder. It's a very aggressive software development because you really don't have time or um, you have time for slowdowns. You do. You're always collaborating, but it's more deliberate in the way it's supposed to have a final product than your RAD or your waterfall models. Even though the agile methodology is the main goal is to provide flexibility because of an interactive approach while ensuring a quality product. That is the biggest item that they have. The constant daily review, the interaction, the deliverable, which has quality behind 100% of the time. The key in here is quality product. During the waterfall and on the red, quality is not mentioned as a very specific item that is a requirement of the software development. As I explained before, in the waterfall, you can get all the way to programming and delivery having problems with quality. Companies are willing to release the software, even though they lack quality on everything they're doing. You, the customer, have been given that quality for you to review and provide feedback. And all of us have done it on where we are given and we buy or we hold with licenses. Lean methodologies. Is design developing a minimum viable product. MVP is a working software application with enough functionality to demonstrate the ideas for the project. So think about it as you're going to create a payroll program because you want to standardize your payroll at your office. The minimum viable product will be, first of all, I collect time from everybody. So first product will have to be collecting time. Once it works, then it goes back and create a second part of the minimum viable product. Now that we have time accumulated, now we got to separate regular time from overtime and so on and so forth. As it continues to develop, it continues to go to the process until it gets to the final process that he wants. The software is gathering feedback in two forms: direct observation and discussion, statistical information gathered from the software. So if I'm doing a payroll program, I'm collecting information from the customer when they punch their time card or their magnetic card is read at the scanner. So I need to go back and talk to the employee. Why don't you have cards? Why don't you have a reader? How do I get that information from the reader? The software that we created tells me that it can scan up to 20 times a day, so it's slow. Or it can scan up to 5,000 scans a day, it's rather fast. Compilation of the data can be done really quick. The database can be read really quick or very slow because we're using the wrong type of compiler, the wrong type of operating system. We're using Microsoft Access versus SQL or Oracle. So this kind of information is what they're gathering. Again, this information is based on the feedback. The team determines the direction of the project. Are we going forward? Are we going to scrap the project? When you look at all the lean developments, they all have different options available. Empower the people because you're giving them feedback and you're requesting feedback from them. You're showing them the functionality of the project to make sure that it works to everything that they decide. Optimize the value streams. Is the information that we're collecting provided back to the proper departments in a timely manner? Are the scanners reading the way it's supposed to be reading? Eliminate waste. Are we working over and over with the same documentation and we have never bothered to consider that it's not reading all the information that is supposed to be reading because we have never finished updating everything that we had. We had waste in our systems. Our systems are not up to date. They're generating 2 emails for every 1 email that we send. It's too much time reading it. Create value for the customer. So when we sell this documentation, this piece of software, when we establish this application, the department that is going to be using it see value on it. So creating value for the customer and empowering the people come hand in hand because when you are empowered the people, the end user has a good experience with it. When a good experience is received from the application of the software, the customer that is buying the license for this software is going to have value. They can see their people are not wasting time. They're optimizing their time at the clock or out of the clock. They're not wasting time because 2 or 3 recordings of the same time are being made, not knowing why. But at the same time, it's continuously improving. It's continuously getting better, trying to collect information. So it builds, it codes the data, measure data, learn from the data and ideas, goes back and build. Lean methodologies are considered a new concept. And it focuses on the previous item of the lean developing a minimum viable product. Thus, the lean development. You produce something small, something that gives functionality. If it works, then we continue to improve it without wasting people's time, wasting people's effort until we get something really fast working for us. The application provides enough functionality to provide the idea behind the software. As we improve it, we get to a point where it's valuable and we can provide feedback to the user and to the buyer and to the actual developing team. As the Other applications, this one also gives the users, the potential users, information so they can review. So it's always continuing to improve. It's always empowering the people. It's allowing them to review the data. It's continuously improved. Therefore, the customer, the final user, actually gets value out of it. Okay. So we have gone through lean methodologies, agile methodologies, RAD application development, and the waterfall model from systems development cycle, life cycle. Again, these systems were created for programmers, for system designers, for shops to use. Does not mean that when you are working on your business processes, you are not using these applications. You have the same format in here to develop a business process, which in turn can actually refer to you an actual application that you can use. There is such a thing called the quality triangle. The quality triangle is designed for developing software or services. This is designed so when you're trying to develop a service or a piece of software or anything, you need to make sure that two, preferably the three items, are always present: time, cost, and quality. The optimal product will address all three items, but you must address a minimum of two items all the time: time and cost. So if you address time and cost, you're sacrificing what? Quality. If you address quality and cost, you're probably sacrificing time. If you have time and quality, you're probably sacrificing cost. As a business manager, as a project manager, as a designer, you are looking to see which one is going to be the most viable option for you to develop the business process or the application software package that you're trying to work with. Because you want to make sure that you have achieved two of the three factors. Each one of these items are in competition with each other. The basic line is, if you are willing and able to spend a lot of money, you're going to have all three. Because then you don't have to worry about time, cost, and quality. Money is quality, money is cost, money is time. If you have unlimited resources of money, you can achieve the three. As a minimum, you have to have two of them in order to develop the product or the service. Main reason why is being said that low cost, high quality projects done quickly are very difficult to achieve. Low cost, high quality are not going to be done on a very short time. It usually takes you time to find the quality that you need. That's going to be the price you're going to pay. It's almost impossible to say that you have low cost and high quality to get all three of them working for you together. Programming languages. Programming language had gone through interactions throughout time. You have different generations of programming language, and depending on who you ask, it begins with machine code, and they're gonna be generations one, two, fourth generation, so on and so forth. Then you have compiled versus interpreted. So besides having the generation software being built, I mean, it's older versus new, you have to compile, you have to work with compiled versus interpreted. Compiled basically means you put the program in a specific format, is written into usually on human design, letters and numbers. Then it has to be translated onto machine language. That's your compile software. Your machine is going to make it into something readable so it can be executable. And therefore it can run the software. If you ever heard of COBOL, C, or C++, those are typical examples of uh, compiled programs. Interpreted languages require what is called a runtime program that has to be installed in order to execute the software. So every time we have to do the interpretation software run, the runtime software has to be loaded. It runs program code line by line, and it runs it. The caveat with the interpreted language is a lot easier to use, but it takes a long time. It takes more resources. Typical example of the interpreted software is basic language, PHP, Perl, Python. HTML is considered an interpreted language because you are using a browser to run the application. They're considering Java exception because Java programming is a hybrid of the interpreted and the compile. Java usually compiles a program to create a program that can be understood by the Java virtual machine, etc., etc. And each software application has a different JVM, which is usually installed before any program can be executed. So unless you're into Java programming, you won't be following this, but it's good to know. You have compiled, interpreted, and now you have a hybrid of in between the items. Then you have procedural versus object-oriented. The procedure language is designed to follow programmers, define a specific starting point, and then execute that specific sequential points. That's how original programs work. They were sequential programming language, they were procedure in sequence. You usually started under a routine, a specific set of routines. Before it could run a next routine, it has to make sure the previous routine was completed. Then it went to the next one. Once it was completed, then it allows you to run. This used to be the way program like COBOL was run, or BASIC. And if you ever run something like this, it ran the instructions, it went through the whole interpretation of what it was doing. And then if you find an error, gives you a message and it stops. So you gotta go back and look at every step of the procedural language that is doing, procedural format, and see where the error was. Then this software evolved, and then it's becoming we have a new application. It's called object-oriented programming. And basically, we're saying that the programmer define objects, like call it meaning routines that is going to perform, and they can be manipulated at a different times of the software. It's like saying run a human resources program and run the payroll part first, but run at the same time, interface with the payroll program, and look at people itself, and then look at all the options that they have for that individual person, whether it's married or single, with dependents, with zero dependents, with extra amounts of money being withdrawn from their checks, and so on and so forth. It's coming this way because you are able to produce a routine by itself called read the software. A second routine says read the employee. A second routine tabulate their time. A third routine called withdraw money. A fifth routine, so on and so forth. All of them are being tied together by sets of instructions. It will not go through all of them unless it's specifically asking you to do that, but it will not do everything at one time. It goes through a sequence of events, and it's a lot easier to handle in the event of an error, because when you have the compartment itself, an object that you created, you're able to go back and says, okay, it's giving me an error on taxes. So you have the procedure on taxes. So you go back and object-oriented part of the taxes and figure out where the problem is. Reporting is the same way. Recording of the documents is the same way. Let's see. Excuse me a moment. I need to step up. Sorry about that. All right. The globalization and the digital divide. The globalization, excuse me. So we're talking about globalization. It means basically the world, correct? Everything we have around, everything that is impacting us, everything that we didn't have access to before. The advent of the internet and communications has brought the world to us. We are no longer A simple location, a small location in a small city or a small country or whatever. Globalization has brought the markets, has brought everything that we deal with on a much larger scale. But if you think about it, globalization has existed as long as colonization has existed. That today, communications and the internet, the 24-hour channel, the news, is bringing everything to us on a immediate feedback. It's a totally different approach. If you think about it, when the first European uh, settlers arrived in the new continent, the Americas, our predecessors, if you may, it took years for them to be able to get information back and forth from where they were coming from. Well, some people say months. I'd say, depending on where you were at, a good year. But it was globalization. A European from Germany, Spain, England was in this country, was in South America, was in Asia, was in Africa, whatever. Information was not available that fast, but it still was available. With the advent of the telephone and the telegraph machine, then we didn't have to wait for months. Now it was a matter of days. For local areas, it was a matter of hours, if not minutes, to get information available. So as you can see, globalization has existed all the way back to colonization of the different areas of the world. Advances in communications and transportation technologies has accelerated everything. The internet is truly a worldwide phenomenon. The fact that so many people are able to reach and access the internet is incredible. Remember when we were talking about ARPANET and the first descriptions of ARPANET, it was designed for the federal government. It was designed so only specific parts of the federal government can use it. Then it evolved into universities could use it. Then it evolved in which certain people could start using it outside of the universities. Then the advent of the first technologies allow us to see writing, not so much graphical user interfaces of what we were seeing across the world. The development of web applications enable us to be able to see better graphic representation of what we were looking at. The internet, as of 2017, estimated 4.1 billion people worldwide were using it. I have in here a site, internetworldstarts.com. Let me share with you this. And this is interesting because this is a statistics as of first quarter of 2021. 53% of the users of the world are in Asia. 14% in Europe. 11% in Africa. 9.6% in Latin America, North America, Canada, and the United States, 6.7%. We think that we are on the internet. We are not. We are one, two, three, four, fifth from the top in users of the internet, which is incredible considering what you have. As of March the 31st, internet users from all over the world are now represented in here. If you go by population and you do the breakdown, the total population recorded 7,875,000,000. Asia alone, 4 billion people. Africa, 1 billion people. Latin America, 659 million. North America, 370 millions. Users, in comparison, we have a very high percentage. We have 74%. Still, we're not at the top, but when you figure, actually, I beg your pardon, we use the most of the internet capacity in relationship to the number of population use in the countries, North America, with a 93.9%, or 6.7% of the whole world. The population in Asia is 63.8%, or 54.3% of the internet of the world. This is only because population-wise, they got 2 billion people. But this has continued to grow. This has not slowed down at all. So when we're talking about the internet statistics of the world, we see the world is connected. A big amount of the people are connected and using the internet. The internet is a conduit on today. Therefore, it has become the globalization tool of business or anything. One of the items that has appeared in here is called the network society. And it's being said that having the world connected via the internet has created massive implications. This is one of them. It's a new global economic activity that is very different from the past. It's an economy with the capacity to work on a unit in real time on a planetary scale. This is a quotation. It's in your book. From the rise of the network society. So we are being told today that our society is part of a network society. And it's true. As long as people are connected to the internet, we're all networking. Because we're all networking, because we're all connected, it developed multiple economies of scale all over the world, all working together for the same goal in real time. As long as you're in the internet, you're basically working in real time. You can do business. What does this mean? This means the world is flat. In 2005, there was a book called The World is Flat. And the world is flat, written by Thomas Friedman, because now, even though we are 10,000 miles away from people in Asia, you can see what they're doing, they can see what we're doing. We are all working along the same lines. So Freeman used to say that globalization has been happening since 1492, and he called it globalization 1.0. This went until around the 1800s, and it was centered around countries, and is designed on horsepower, wind power, and steam power. Then it happened globalization 2.0 from 1800 to the 2000. And it's important because the two World War wars interrupted globalization. Companies began to appear, companies began to become multinational companies. They appeared in more than one country. And the world, because of this, began to change from a medium-sized world to a small world. Everything can be reached because of the globalization that is happening. Globalization 3.0 is our current area, beginning in the 2000. So we're going on 21 years. He talks about the convergence of the personal computer, fiber optic, internet connections. Software has created a flat world platform. A group or an individual can be global. Thomas Friedman says the world is now tiny in size. And Friedman also states that the globalization has changed the world because of information technology. And he goes to describe the graphic user interface for the personal computer in the 1980s, the GUIs. We no longer have the Amber monitor. Now we have the Windows and the Apple graphic user interfaces. The build out of the internet from the .com forward during the late 90s, where companies began to see that they could do business, that they no longer have to be in one centric location. The advent of email, HTML, communications and networks, they become a standard. They are no longer the only item. It was now a standard item for our productivity. It's like today, email and web browsers are important items of our daily life. The introduction of software to automate and integrate business processes. So as we continue to introduce software that enable us to automate everything, to facilitate other things, other tasks, other processes, we begin to create a workflow in here that technically is allowing us to work more easily, allowing software and databases to integrate like a payment process system. You can actually work anywhere in the world with it. They are working together, or a shipping calculator. They can be integrated to work wherever you are with whatever system you have available. So as these companies come together, as these processes and business applications come together, we get to see a reduction on things, because now we're no longer a centric society. Now we're a global society living on the new technology capacities. We see things like mail letters. They are reduced drastically. And the letters that go across countries are now reducing to a 1%. Telephone calls. Telephone calls that are now specifically labeled as international calls. They are nearly non existent because now telephones can call almost everywhere. Internet traffic now is routed across multiple borders. There are locations where there are limitations, but it's basically going everywhere. So globalization has brought us a lot of changes. And one of the changes that we have seen that is very palpable is the global firm. So what is a global firm? All we need to think about are most common firms that we know, huge, big, that have their hands everywhere, have businesses everywhere, touch everything that we're doing in any way or another. We want to think of Walmart. Walmart is opening stores nearly everywhere they go, and they have warehousing nearly everywhere they are. They have production facilities across the world. It's a global company. They work 24 hours a day around the world, and they have expertise in labor and markets around the world. They have open markets, large markets for all of their products. They have to deal with the infrastructure differences because each country has a different form of doing business. Labors and law regulations, legal restrictions, language, customs, preferences. Every country has different, every region has different. A firm that is able to handle that is very important to be considered a global firm. And of course, shipping. Shipping has become an international mainstay of doing business. The global market has to be able to handle international shipping effectively, economically, and with accuracy of delivery. Without that, it cannot function or facilitate its growth or its mainstay. We have the digital divide. Internet continues to grow. It continues to be big, connected everywhere. But at the same time that this is happening, it's creating a separation between the people who has it and the people who do not have it. This is being called the separation divide, and it's a item of great concern because a lot of people are being left behind. This is being addressed in many different ways across the world to facilitate accessibility to people. You hear every day of new business ventures like Google that is trying to create satellite systems where you can actually access the internet anywhere in the world, or have low cost internet to people, or free internet. So it's because they're trying to slow down and to reduce that digital divide. People have called it the haves and the have-nots of information because it's a gap that exists, and it's a gap that continues to increases. We even see it in our cities, we're seeing it in our schools, we're seeing it everywhere. The bigger the city, the bigger the broadband, the more developed it is. The smaller the city, the lower the capacity, the slower the capacity. So this is part of the items that create a digital divide. Even though we have a great amount of internet usage, we do show that there is a digital divide. And the digital divide is a substandard or a sub model of economic divides. People don't have the capacity economically to connect because cost, because they cannot afford the connectivity, they cannot afford the hardware, the software. So people come up with different options to try to resolve this. But again, economic divide has been part of this digital divide. Usability, the more complicated the systems become, the more difficult it is to use, therefore increases the digital divide or the separation with the people because they don't have the capacity or the way to use a sophisticated application. They are called also to an empowerment divide because it's the most difficult to solve. How do we use technology to empower ourselves? Very few people actually contribute to the content on the internet. Many people limit themselves by what they can do online by accepting default settings. And people do not work so they can understand or they can take advantage of all these capacities that they have with their equipment and their software. So empowerment divide is present, but if you think about it, the empowerment divide comes from the person that probably has the usability, not the divide, probably has some kind of economic capacity, but never step to go forward with it. Some people have stated that the empowerment divide can come in the sense of the older adult that at the same time that he has the usability divide, it also comes to the empowerment. They don't want to learn. They don't want to go try to do something new. They want to be able to use their basic software and use it, and that's it. So understanding these stages of the divide helps us to see what needs to be done to address this digital divide. How can we make it better? How we can decrease it? How we can garner a better economic growth? How we can have different aspects that will apply in here and will enable us to understand and better our situation. Information technology has driven the change at a global scale. That is basically what is happening right now with us across the board. We started with software development, creating software. Now we're being seen that all the software that we write, all the new tools that we have, all the workflows that we have are creating for us a driven change at a global scale because of the internet. We have integrated people from all walks of life all over the world by using these tools. The businesses have capacity to increase the labor pools. They have the capacity to increase the labor markets and their operating hours, especially if they work global. They can work all the time. So many implications for businesses, for people, for governments. It's a new globalization that has exacerbated the digital divide. Time will tell when we can resolve that. We can continue to strive for a better resolution, but it's not going to happen fast. We have to be aware that exists and continue to strive to a better resolution for it. This is all I have for tonight. A short chapter, a lot of information, not all applicable, but to your projects, but important to understand that many of the items that we covered tonight are no longer plain programming. They can also be used in many different ways by you in your application in business and in business processes. This is all I have for tonight. I thank you for being here and participating on this class. Uh, Continue working on your projects. Please don't let that go. Again, if you have items that are still pending on your homework, let me know. That way I can go back and send you that information. There is no more homeworks for the class. Only homework is your own work on the projects, okay? And the discussions. We have two more discussions. This started, the one that is opening tonight and the one that opens next Wednesday. I think that you're gonna like them. They are rather good and interesting. Hope you keep participating the way you participated on 5 and 4 and 3 and all of them. So that's all we have for tonight. Enjoy your weekend. Don't work too hard. Stay dry. Stay safe. Good night, all.
Thank you and good night.
Thank you, Professor.
Thank you,
night,
guys.
sir. Actually, if you're still here,
Yes,
you
sir.
mind if I ask a question?
Of course. Go ahead.
So I was curious, just your opinion, really. We were discussing, or you were presenting, the broadband deficit that we have in certain areas in the United States,
Right.
and just happens to be that I work in that field, and so I was going to ask you how you feel about the new infrastructure program that's being presented by our administration on expanding the broadband, and how do you feel if that's something the government would do, or is that still going to be private sector?
All right. This is not a trick
Can of
question.
worms.
Okay.
No, I'm interested. So I'm in sales, and so it affects me specifically because obviously if it goes government, then I'm out of a job basically.
I agree.
Yeah.
My personal opinion from the point of view of business, private enterprise have always been forward on the development and application of everything. Government works for us and with us. Government facilitates, but it's private enterprise the one that does the research and development and installation. G5, for example, 5G.
Yes, sir.
5G, for example, is the most common issue. I have never seen a tower being installed by the federal government.
Right.
I have never seen a tower being replaced by the federal government after a hurricane. It was AT&T, it was Verizon, the ones who did it.
Right.
As far as the infrastructure, I think that if the infrastructure program does enable the private enterprise to step up and say, here what we have, this is where we want to be. I want to have coverage at 100% capacity on these locations. If the coverage is available, then it's a matter to getting the user to the coverage capacity. We see it today. Nearly every person in this country that pays for their utilities and telephone bill has a tax added to subsidize internet and telephone for people that can't. Be it as it may, like it or dislike it, it's there. So if Verizon, AT&T, T-Mobile, Sprint went ahead and put lines with delivery capacity for 5G, 4G, 3G, depending on what you are, now every person that has accessibility to the internet via telephone will be able to get it. So I'm not saying AT&T give your product for free, or the federal government, will be installing all the towers and developing the 5G product. Will be in the dark ages if they do that. They do not work. The government needs to go back and let private enterprise run their business.
Do what they do.
That's what they do.
I like that. I like that.
That's how it should be. I'm a firm believer the government has great ideas, but the innovators have been the private companies, the enterprise.
Right. All
The
right.
enterprise have been doing the research, and the enterprise have been doing everything they need to do to